All right, welcome guys. Today we're going to go over a sample exam from previous years for midterm 1. If you have any questions at any time, please stop me and ask, and I'll do my best to address them. All right, so we have 25 questions here. The first 10 are going to be based on this graph. All right, so in this graph we have a supply curve, a demand curve. At some point they intersect. The first question is, what is the equilibrium price of this good? So to find the equilibrium price, what do we need to do? We need to find the point, yeah?
Set them equal to each other?
Right, set them equal to each other. In this case, we have a graph. So we just find the point at which they intersect, right? And then track, on the y-axis, we track what the price is. So this is their intersection point. At equilibrium, the price is going to be 11, exactly. And what is the equilibrium quantity then? You find that by going to the x-axis, right? So the equilibrium quantity would be 12, right? So 12,000, because this is in thousand. All right, so this question was, what is the equilibrium price of this good? And the answer was 11. So that's B. All right, that's straightforward. Okay, sorry. Next question. If a price ceiling of $13 is imposed on this good, what is the consequence? Okay, so first of all, we have a price ceiling. What does that say? It says we cannot sell this good for more than $13, right? So first of all, interpretation. A price ceiling means we cannot sell for more than whatever the price ceiling is. In this case, it's $13. The next question you need to ask yourself is whether that price ceiling is binding or not binding. And that could be rephrased as to ask whether after the price ceiling is imposed, is it still legal to sell the good at the equilibrium price, right? So it's no longer legal to sell above 13. Are we trying to? What is the price that we're selling at currently? 11. So we are not in violation of the price ceiling, right? What does that mean? Is it binding or not binding?
Not binding.
Not binding, right? So in this case, because the price ceiling is above our equilibrium price, right? It does not affect the market. The market is still going to operate at equilibrium. This is not going to be binding, so there is nothing, right? No effect. Now, if it were, instead of price ceiling, if it were a price floor, right? So price floor tells us we cannot sell for below that price. Okay, are we trying to?
Yeah.
Right, if there were a price floor of 13 instead of price ceiling, right? Then we would be in violation because we are trying to sell at 11, which is below the minimum price allowed. So then we will have a binding price floor. And what's the consequence of that? What's going to happen? So if it were a price floor here at 13, then we're going to have, right, quantity supplied would be higher than quantity demanded, right, at that price floor. So we would have a surplus. Exactly. Alternatively, so let's say there was a price ceiling of 8. Okay, so now we cannot sell for more than 8. Is that binding or not binding?
Binding.
That will be binding. And then what's the consequence? A shortage, right? Because at 8, we would have more demand than supply. And then we'll have a shortage. Right? Does that make sense? Okay. So right, in this case, the ceiling was not binding, so the answer is D. Okay. If a tax of $7 is imposed on this good, what is the deadweight loss? Okay, so let's start from the beginning. Whenever you impose a tax, there is one consequence that's going to happen for sure, and that is the quantity after tax is going to be lower than the quantity at equilibrium. So basically, we will be moving to the left of our equilibrium. And always, when you have a tax, the price that buyers pay is going to be higher than the price that sellers receive. right? Because government takes a little bit too in the form of the tax. So it's always going to be the case that the price that you get from the demand curve or that buyers pay minus the price that suppliers receive is going to be equal to the tax amount. Right? To find, in this case, we have a tax of $7. To find exactly what quantity that happens, we need to then look at where the difference between the two curves is going to be 7 on the left side of the equilibrium. So when we basically have a graph, so we just can count the squares and see where the difference between the two is 7. And that happens, I think, here. So it's 1, 2, 3, 4, 5, 6, 7. So exactly here is where the tax is going to take us. Right? So this difference here is going to be the amount of the tax, which is 7. And if you take this to the x-axis, then you can find what is the quantity after the tax, right? The quantity bought and sold. And we see that this is going to be 6,000 now. This is the quantity after tax. Right, so the question is about the deadweight loss. What is a deadweight loss? We know that the original equilibrium is the point at which the market is efficient. In economics, that would mean that total surplus is maximized. Right? So if we are at the equilibrium point, total surplus is going to be the sum of consumer and producer surplus. Right? And so consumer surplus is the area below the demand curve and above the price by definition. Right? So consumer surplus would be this whole area. And producer surplus is the area above the supply curve below the price. So this area here is going to be producer surplus. At the original equilibrium, we have efficiency, so the total surplus, the sum between those two, is maximized. And the total surplus is the area of this big triangle, right? Now, after we imposed the tax, we saw that the consequence was a reduction in the quantity, right? So the market is no longer efficient, and we are losing a bit of total surplus, right? So after the tax is imposed, then the total surplus would just be this trapezoid here, right? So deadweight loss is actually the difference between total surplus in equilibrium and total surplus after the imposition of the tax. Or if you look at the picture, it's basically the deadweight loss is the area of this triangle here, right? Because that no longer goes to anybody. This is lost. Okay. So this will be our deadweight loss. Okay, so in terms of a formula, right? So a theoretical way to calculate the deadweight loss, let's look at what the area of this triangle entails. So deadweight loss is always going to be, first of all, the base of this triangle is always going to be the tax amount, right? Because it's the difference between the price of the demand curve, the price of the supply curve. So the base of this triangle is always going to be the tax, right? And then the height of this triangle is going to be what? From here to there. Well, this is the change in quantity, right? So it's the difference between the quantity in equilibrium and the quantity after tax. So it's going to be the quantity in equilibrium minus the quantity after tax. And this is always going to be positive because we are reducing the quantity after the tax, right? And then it's a triangle, so the whole thing divided by 2. Right? This is a formula that you can use in any situation. If you have the curve, you can apply this. If you have the equations of the two lines, you can also apply this. So now it's just a question of plugging it in, right, and solving. So in our case, what was the tax? 7 times, what is the quantity in equilibrium? 12,000. I'll add the 1,000 at the end. And what is the quantity after tax we saw? It was 6. Right? The whole thing divided by 2. So we have 7 times 6 divided by 2, which is 21. But the quantity is in thousands, so it's $21,000. Right? Does that make sense? Okay, so we lost 21,000 of total surplus because we imposed this tax. So that's answer A. Okay. Next question is, what is total surplus and equilibrium? All right, so we already discussed that. Total surplus is going to be the sum of consumer surplus and producer surplus, right, in equilibrium. So it's the area of this whole big triangle, right? And again, if you want to have this as a formula, let's figure out what the area of that triangle is. So the base of the triangle is, it goes from here to there. What is this point? What do we call it?
17.
What is it theoretically? It is 17 in this case, but what does it represent? The intercept of the demand curve, exactly, right? So this point here is the intercept of the demand curve. And this point here, the intercept of the supply curve. So the base of the triangle is always going to be the difference between the two intercepts, right? So total surplus can be written as the base is the intercept of the demand curve minus the intercept of the supply curve. And then the height of this triangle is what? From here to there. What is this? How can we represent this? That's the quantity in equilibrium, right? So times the quantity in equilibrium. It's a triangle, so the whole thing divided by 2. And now we have a formula. We just need to plug in the numbers, right? So this is applicable to any situation you have. In our particular case, the intercept of the demand curve is 17, right? Minus, 3 is the intercept of the supply curve. And the quantity in equilibrium we said was 12, right? The whole thing divided by 2. So what is it? 14 times 12 divided by 2. 7 times 12, 84, right? And then quantity is in thousands, so it's 84,000. Okay, any questions? All right, so answer D in this case. Okay, next question is, use the midpoint method to calculate the price elasticity of supply between prices of 7 and 9. Okay, so what does the midpoint method tell us to do? To calculate the price elasticity, now note that this is the supply curve, and that's important, right? So we're looking for the elasticity of the supply curve between those 2 points. The elasticity of supply, using the midpoint formula, is going to be, okay, so basically you have 2 points, right? 2 points on the curve, and you need to find the elasticity between them. Those 2 points are characterized by quantity and price, right? So you have 2 quantities, 2 corresponding prices, and the formula is the difference between the quantities, and again, this is the supply curve, so make sure you keep that in mind, divided by then the average of the quantities, right? So it's going to be Q1 plus Q2 divided by 2. And then this whole thing, let's put it here, divided by the same but for the prices. So the difference between the price 2 minus price 1 over the average of those 2 prices. Okay. I'll write it nicely on the other side. All right, so now we need to see what those points are. So we're on the supply curve between the prices of 7 and 9. So I know the first price is 7, the second price is 9. Now I need to find the corresponding quantities, right? So at price of 7, what is quantity supplied? And at price of 9, what is quantity supplied? And this is where you need to be careful that you're asked about the supply curve, right? Because the answer would be different if you're looking at the demand. All right, let me find this. So at price of 7, which is here, the quantity supplied is going to be 6. And at a price of 9, which is there, the quantity supplied would be 9. All right. Now that we have that, it's a matter of plugging in and solving. All right. So elasticity of supply between those 2 points is the difference between, so 9 minus 6, right, divided by the average between 9 and 6, which is 7.5. So it's 9 plus 6, 15, divided by 2, 7.5. Right? And this whole thing then divided by the difference in the prices, which is 9 minus 7, right, divided by the average, which is 8. Right? Okay, so let's see what I have. I have 3. And 7.5 is 15 over 2. Right? So I can bring the 2 here. And I have 3 times 2 over 15. The whole thing divided by 2 over 8. Okay. This can cancel. So I have 2 over 5. And when you divide by a fraction, actually this becomes 1 over 4. When you divide by a fraction, it's the same as multiplying by the reciprocal. Okay. So times 4 over 1. And what do we have? 8 over 5. That's 1.6. Yeah. Okay. So just be careful in the calculations. And which curve are you asked about? So the answer here is going to be C. Now, if it were the demand curve, then we would do exactly the same, but instead of tracing the supply one, we would, at the price of 7, then quantity demanded would be over here, right? And at the price of 9, quantity demanded will be over there somewhere. So you basically just have to trace the demand curve. Question?
We can use our calculator for that question, right?
The question is if you can use your calculator for that. I mean, I don't know what your professor's policy is, but I assume it would be okay. Yeah, I mean, yeah, if she allows calculators, then yeah. I'm not sure though. All right, any other questions? All right. Which one of the following is the equation for the supply curve? Okay. So we're given the graph and asked to find the equation of the supply curve. So the supply curve is a straight line, right? So any straight line has the following form. Y equals b plus mx, right? Where y is the variable on the y-axis, x is the one on the x-axis, b is the intercept, m is the slope. Right? So what's the first thing we can do is find the intercept. We already did that, right? What's the intercept of the supply curve? It's going to be 3. Right? We saw that this is it. So we know that b is 3. We're over here. Well, that does not help us narrow it down because all of the answers have an intercept of 3. However, what else do we know about the supply curve? It has a positive slope. All right? So it's going to be positive. We don't know what it is, but it's going to be a positive slope. So right now we can discard C and D, right? Because they give you a negative slope. And now the question becomes, is the slope of the supply curve 3 over 2 or 2 over 3? Okay? And to find the slope of any line, you can pick any 2 points. Right? Look at the rise over the run. Okay? So just pick 2 that look nicely, like this one and that one, for example. Right? From here to there, the rise is 2, and the run 3. So rise over run means that the slope is 2/3. And y is going to be the price, x is going to be the quantity. Right? So we can have the supply curve now is 3 plus 2/3 times the quantity. Right? What is the, so the answer here is B. What is the equation of the demand curve? So again, it's B plus mx. So what is the intercept? All right. So for the demand curve, we're going to have 17, then plus or minus, right? The demand curve is downward sloping, so the slope is going to be negative. The slope times the quantity. And what's the slope? We can just choose any 2 points again. Like here and there looks nicely. What's the rise? Over? So 1/2. Right? Okay. In this case, it was B. Using the point slope formula, what is the price elasticity of demand in equilibrium? All right. So what's the point slope formula? At any point, the elasticity is going to be equal to 1 over the absolute value of the slope of that curve times price over quantity. Correct? Now we are asked about the price elasticity of demand in equilibrium. So again, it's important that we are asked about demand in this case, because then we have the slope of the demand curve that we're going to plug in here. And it's in equilibrium, so we're going to plug in the equilibrium price and quantity. Now we actually know all of this, right? So what's the price in equilibrium? What was it? 11. Quantity? 12. And what's the slope of the demand curve in absolute value? We just did it, right? 1/2. Now plug in and solve. So the point elasticity of demand at equilibrium is 1 over 1/2 times 11 over 12. I can put the 2 on top. So it's 2 over 1 times 11 over 12. It's 11 over 6, which is about, it's less than 2, 1.83 must be the answer. All right? So in this case, the answer is B. If it was asking for the elasticity of supply instead, the only thing that's going to change is that here we will plug in the slope of the supply curve. Okay?
I have a question.
Sure.
To go in another way, what about if you compare those two equations, the demand and the supply equation, and from there we're gonna, because their intersection is gonna be the equilibrium?
Right. The next 7 questions after this are going to give you the equations and ask you all those questions or similar questions. So you can either have the graph, and from the graph you can figure out the exact.
No, I'm talking about specific this.
In this particular question?
Yeah.
So
remember that, PD, you calculate PD that you didn't ask about you calculating.
we calculated the.
Here 17 minus 1/2 by P.
Right.
And
That is the formula for the demand curve.
yes. Okay, and here for the supply.
And that's the formula for the supply curve,
Yeah.
yes.
If you compare those two equations, you can find the
Right. Exactly. So if you are given the 2 equations and you set them, so if you're given just the 2 equations and asked about the equilibrium, you would set them equal to each other to solve for the quantity in equilibrium. then it will take that quantity, plug it in either of the two to get the price. Right? So if you do that here, you would find again that the price in equilibrium is 11 and quantity is 12. But because we also have the graph, we can just figure it out from the graph. Right? All right. Okay, so what is the proportion of tax incidence on buyers for a tax of less than $14 per unit? Okay. So basically, what percentage of the tax, or what fraction of the tax, are buyers going to end up paying if a tax is imposed? And let me ask you this. What is the significance of this 14 here? Why does it matter that the tax should be less than 14 per unit?
Because the intersection, the difference between intersections is 14.
Right, exactly. Because the maximum it can go is 14. If you charge a tax of 15, there's no market anymore, right? There's not going to be any quantity sold at all. So that's that part. Okay. What is the proportion of tax incidence on buyers for a tax of less than 14 per unit? Let me ask you this then. Does it matter whether you impose the tax on the buyer or on the supplier? Right. It does not matter. It doesn't matter who ends up paying it, like physically paying the money to the government. The tax incidence is constant. Well, constant in this case because the way the curves are being linear. And you can find it by, again, a formula. Okay. So it doesn't matter who actually pays the tax. Buyers are always going to pay the ratio of this distance to the whole, to the difference between the two intercepts. And the sellers are always going to be responsible for 1 minus that. Okay? So again, to put it as a formula that you can apply later, the tax incidence on buyers is always going to be the ratio of, what is the length of this side? It's the difference between the demand intercept and the price in equilibrium, right? So it's always going to be demand intercept minus price in equilibrium divided by, and this whole distance we said is the difference between the two intercepts. Okay? The intercept of the demand minus the intercept of the supply. That is always going to be the case. And the tax incidence on producers or suppliers is going to be the ratio of that part here divided by the whole, and this is the price in equilibrium minus the intercept of the supply curve, again divided by the difference in the intercepts. All right. So whenever you're asked about tax incidence, you can use those formulas. And we are asked about tax incidence on buyers. So we're just going to plug in the values. What was the intercept of the demand curve?
17.
Right? And the price in equilibrium? 11. Right? So 17 minus 11 divided by, again, 17 minus 3. Or it's 6 over 14, or 3 over 7, which is A, right? Yeah. So whoever is actually charged the tax doesn't matter. Buyers are always going to end up paying 3/7 of it, and suppliers are always going to end up paying 4/7 of it. Right? Sorry? That's what once we impose the tax, we're not going to be at equilibrium anymore, right? but it's no matter how big the tax is, that's the proportion of money that the buyers and the suppliers are going to end up paying. Question?
Why for the two different equations are they switched? Like in the first one, it's
Well, look at the formula, right? Look at the graph. So the tax incidence on buyers is this divided by the whole, and this distance here is the difference between the demand intercept and the price in equilibrium. For suppliers, it's going to be that part, that distance, divided by the whole, and that distance is the price in equilibrium minus the supply. Okay? Question? No? All right. So in our example from before, when there was a tax of $7, right? Buyers are always going to pay 3 of it or end up losing $3 because of it, and suppliers 4. Okay? Right. The answer here is A. What is the maximum surplus available to workers given a minimum wage of $14? All right. So now we are at, this is the market for labor, okay, because we have workers and minimum wage. So this is the market for labor. This is the price of labor or wage, and this is the supply of labor. In this scenario, are the workers buyers or suppliers? Suppliers, right? They supply the labor. So this question is, if there is a minimum wage of 14, meaning that if there is a price floor of 14, right, that's what minimum wage is, what is going to be the maximum surplus available to producers? Right? So at a price floor of 14, what is producer surplus? That's what this question is. So we have a price floor, means we cannot sell for less than 14. Are we trying to? Yeah, right? Because in equilibrium we had a price of 11. Now that's no longer legal, right? Because there's a minimum wage of 14, so a wage of 11 is no longer legal. Therefore, this price floor is binding. Right? And let's see what happens when we impose it. 14 is right here. Okay, so when you have a binding price floor, you have more supply than demand. So what do we get? Surplus or unemployment. Right? So this is the surplus. Now the question is, what is the surplus available to workers? So what is producer surplus? Well, this is the point at which the market is going to operate. Right? Because there's at this price of 14, the demand for labor is only 6,000 hours, let's say. Right? At that point, what is consumer surplus? Well, by definition, above the price and below the demand curve, right? So this little triangle here is consumer surplus. And producer surplus is below the price and above the supply curve. So its area is actually this trapezoid here. That's going to be producer surplus, and that's what we are asked about.
In this case, the $14 acts as a tax, right? For lack of a, just so I understand it.
It has the same effect in the sense that it reduces quantity and equilibrium, but the government doesn't take it. Yeah.
But it acts as a
In terms of deadweight loss, yeah. But now, when you have a tax, the surplus that results after the market clears goes to buyers, suppliers, and government, right? Now, when you don't have a tax, it goes only to suppliers and the buyers.
Could you please define binding and non-binding?
to define binding and not binding. All right. Well, the way I think about it is I first figure out what the rule is, what the new regulation says, and then to figure out whether it's binding or not binding, I ask myself, is the initial equilibrium legal or not? So like in the first scenario, we had a price ceiling that was at 13 or something, right, above the equilibrium price. And that price ceiling says you cannot sell for more than that. But we weren't trying to, right? So nothing is going to change. Because the equilibrium is still legal after the new regulation, right? Now in this case, because we have a price floor, which says you cannot sell for less than 14, and we are trying to sell for less than 14, so that's no longer legal. And when that happens, then it is binding. It means it has consequences. If it's not binding, it doesn't have any consequences. Nothing's changing. All right? Sure. Wait, okay, so surplus available to workers. So producer surplus, as we said, that's the area of that trapezoid. It's A plus B divided by 2 times H. So the base of the trapezoid is here to there. What is this quantity? Well, it's 14 minus 3, right? What is it, 11? And this here, this side of the trapezoid is, well, that's actually 7. Right? We figured that out before, but you can count it out. It's 7 divided by 2. And then the height is, that's the quantity after the floor is imposed, which was 6. So what do we have? 18 divided by 2 is 9 times 6, 54. So 54,000 is the maximum available surplus to workers in this market. Question? This is just the formula for area of a trapezoid. Sorry. Okay. All right, that's a trapezoid. This is the base, one of the bases. This is the other base, or the top and the bottom, pretty much. And then the distance between them is the height. And in this case, we have the distance because it's one of the angles is right of this trapezoid. Does that make sense? Yeah. So A plus B times, and this is H. A plus B divided by 2 times H is the formula for area. All right. Where's my thing? This is answer A.
What was the minimum surplus? This is for the maximum surplus. What if we ask for a minimum?
The question is this: what if we ask for the minimum surplus?
It's maximum. This one is maximum, but I just want to know what's the minimum supply.
In case that we change the question to find out the minimum.
There's no minimum. I mean, minimum surplus is 0, but then that means that there's no market. The way this, maybe I guess it's not asked correctly. There's no, when the minimum surplus is 0, if nobody wants to work. But we know that's not going to happen in this case. Right? Okay. Suppose the cost of suppliers increases and the willingness to pay of buyers increases. Which of the following combinations of equilibrium price and quantity are possible? Okay. So basically we have shifts, 2 shifts, one in the supply and one in the demand curve. And whenever you have that scenario, I would start by drawing it and then looking at what's happening after the shifts. So we have some supply and demand. Okay. Now we are told, suppose the cost of suppliers increases. Would that affect the supply curve or the demand curve? The supply, is it going to shift to the left or to the right? To the left, so that's a what we call a decrease in supply. All right, a shift to the left. So we're going to have a new supply curve. And the willingness to pay of buyers increases. Does that affect supply or demand? Demand. To the left or to the right? To the right. Now demand increases. Right? Demand itself is the willingness to pay. So this basically says the demand curve is increasing, which is a shift to the right. Okay. All right. So now we're going to have a new equilibrium. What do we know about that equilibrium point in terms of its price and its quantity compared to the initial one? So this was the initial equilibrium here with certain price and certain quantity. Given those two shifts, what do we know about the new price? It's always going to be higher, right, than the original equilibrium. So the new one is always going to be higher than the original. Right? Because the way the shifts work, they're always going to end up at point that's above the initial price. Okay, so we know the price is going to be higher. What do we know about the quantity, the new quantity? It depends, all right? So you can imagine a shift where it ends up being smaller, right? So if the supply curve shifts a lot, we're going to be here. And if the demand curve shifts a lot, we're going to be there. So this is not clear cut. We don't know what the effect on the quantity is. Okay, so given that, let's look at the answers. First of all, we know for sure that the price is going to be higher. The original price was 11, right? It was 11 right here. So we can exclude A and B, right? 12 and 14 are still possible, right? Because they're higher than 11. And then we have, basically those are two different points. How can we judge which one of them is possible? Well, if you look at this as 4 different quadrants, right? This part and then this one. We do know that wherever this point is going to end up being in this quadrant, right? It's going to be above the two curves. So we know we need to be somewhere in here, correct? Now plot those 2 points, and one of them is going to be in there, the other one is not. So at a price of 12 and quantity 16, price of 12, where is 16? We're actually outside of it, right? And there's no way to get there because that would mean that supply needs to move to the right, and we know that it moves to the left. Okay, so that point is not possible. And the only one is answer D, but just to verify, at the price of 14 and quantity of 8, that's 14, 8 is 7, 8 here. Now we are where we should be. All right? Does that make sense?
Can you explain again how the new...
Which part? This part?
No, the area where the new area is going to be above of the new equilibrium. I didn't get it.
Oh, okay. So you want me to explain why were we going to end up in here?
Yes.
Well, this is our starting point, right? The two curves can shift left or right,
Okay.
right? We do know that the supply curve is going this way,
Yes.
and the demand curve is going that way. So their intersection can only be above the supply and demand curve in this quadrant here. There's no way for them to move to the left and to the right and intersect here, right? So if you want to end up here, what needs to happen is supply needs to decrease and demand needs to increase. We have demand increasing, but supply to end up here, demand needs to move to the left, supply needs to move to the right. We cannot end up here because we know the supply is shifting the other direction. You see what I'm saying? Let me try again. Okay. Original supply and demand, right? to end up here as an intersection between the two, okay? Supply curve needs to move to the right. So it's somewhere in here. Demand curve also needs to move to the right. But in this case, we are given that supply is shifting to the left, right? Because we know that the cost to suppliers is increasing.
Everything's increasing, yeah.
Yeah, the cost of suppliers is increasing, so we know that supply does not go that way. It goes the other way. So here is impossible. To end up in this quadrant, well, again, supply needs to go to the right, and it does not. So we know we're not going to end up here. And to end up in this quadrant, demand needs to go to the left, but we know it doesn't. All right, so the only possibility is in this quadrant over here. We don't know exactly where, but we know we're going to be in there somewhere. Does that make sense? All right, now Paloma's going to take over for the rest of the next 7 questions. Clean this up.
Can you hear me? Yes? Okay. I'm very loud, so. Okay, good. So the answer is D. Okay, so the last 10 questions were solving the market equilibrium, consumer surplus, producer surplus, deadweight loss, etc. with a graph. Now we are going to do the same type of exercises, but as you were asking, how can you do this with the equation? Okay, here we have the equation for the supply function and the demand function, and we are going to have 7 questions based on that scenario where you just have to do the algebra to find the answers, okay? So the first question is, what is the equilibrium price? How do you find the equilibrium price? You make, yes?
Set them equal to each other, the two.
Yes, exactly. So you make demand equal to supply. How do you do that? You make the demand function 54 minus 1.5 Q equal, and this is my equilibrium quantity, equal to 6 plus 2.5 Q, okay? In this case, the Q of demand and the Q of supply are the same because we are in equilibrium, so I put a star in it, okay? And then you just solve this algebraically. 54, these 6 come here, and the quantities go, both are on the same side. Minus 1.5 Q. This is equal to 48. Equal to 4Q, then the quantities are 12, right? How do you find the price with this? Okay, you plug it in one of the equations. Since they are both equal, it doesn't matter. So I did it with the supply curve. So price is equal to 6 plus 2.5 times Q, 6 plus 2.5 times 12, okay, and this is equal to 36, okay? And 36 is C, so the answer is C. Is that clear? Okay? You set them equal, you find the quantity, and then you plug the quantity either on the supply function or on the demand function. Okay. So we have, let me write down here, price is 36, quantity is 12. So the next question is, what is the producer's surplus in equilibrium? So what is the producer's surplus? We have my demand function, my supply function, and the producer surplus is this, right? the difference between the equilibrium price, which in this case is 36, I'm sorry, okay, and the supply curve, so this whole triangle. I know that my intercept here is what? 6, right? And I know that my equilibrium quantities are 12,000, okay? So what is my producer surplus? Is 36 minus 6, the base here, which is 30, times 12, which is the equilibrium quantities, divided by 2. And that is equal to? $1.8, exactly. So this is equal to 18, and because the quantities are in thousands, this is equal to 180. This is equal to 180,000, which is A. Is it clear? Okay? Good. Okay, now, again, price is equal to 36, quantity is equal to 12. We are going to need this. So, what is the producer surplus? Oh, okay, I'm sorry. Which curve is more elastic in equilibrium? So, what do we do here? We calculate the elasticity in equilibrium for the demand function and for the supply function. What do we use? The point elasticity formula that we mentioned before. So the elasticity is equal to price over quantity times 1 over the absolute value of the slope, right? So the elasticity of demand, the point elasticity of demand is going to be equal to 36 divided by 12 times 1 over 1.5, right? And the elasticity, the point elasticity of supply, because this is asking me which curve is more elastic in equilibrium, that's why I use the point elasticity, okay? Because it's in that specific point, the equilibrium point. So then, here, times 2.5, okay? And this number is 36 divided by 12 is 3 divided by 1.5. This is 3 divided by 2.5. This is 2, and this is 1.2, okay? So, which curve is more elastic in equilibrium? Demand or supply? Demand, okay? Because the elasticity of demand is bigger than the elasticity of supply, okay? So our answer here is demand A. Okay? Yes?
Why did you use the point slope formula?
Because it is asking me in equilibrium. So the equilibrium is a point on the demand function or on the supply function, okay? The equilibrium point is price equal 36, quantity equals 12, right? The other elasticity formula for supply or for demand, you have to find 2 points, okay? And the difference and then the ratio between this and this one, okay? Here is the point, it is asking you in equilibrium, so it is asking you the elasticity at a specific point, okay?
So whenever it's at a specific point, you use the point.
You use the point, exactly, yes. In most of the exams, this is the type of in equilibrium. When it is asking about in equilibrium, it is referring to the equilibrium point, and you use the point elasticity formula. Okay. So our question 14. This is asking, what is the deadweight loss associated with a tax of 12 per unit? Okay? So what do we do here? We have our demand and our supply function, okay? What is a tax? A tax is something extra on the price, right? So it doesn't matter, when they tell me this, it doesn't matter if it is on the supply or on the demand function. Let's do it on the demand function. So this tax of 12 changes the demand function in the following way. Price plus the tax is equal to 54 minus 1.5 times the quantities, okay? This is like, no matter what the tax is the price plus the tax equal to the demand function. So now let's change this by 12 and rearrange. So price is equal to 54 minus 12 minus 1.5 Q. Is that clear? Is it clear what I just did? So this is basically changing my demand function to price equal 42 minus 1.5 Q. So basically what I did was that I shifted my demand function, the amount of the tax down, okay? I shifted my demand function 12. Okay, now here my intercept is 42. Is that clear? Okay, good. So now what is it that I need to know? The deadweight loss. So what is the deadweight loss? This one was my equilibrium price before, 36. This one was my equilibrium quantity, 12, right? Now, how do I calculate the deadweight loss? I have my new tax. This is the revenue of the tax that goes to the government. And this is the deadweight loss. So what I need to know, with this formula here is the size of this area, right? So I need to know the size of this area is the amount of the tax, okay, which is 12, okay, and the difference in quantities, right? So how do I calculate the difference in quantities? I calculate the intercept point between the demand that I shifted and the original supply function. And this gives me the quantities that are going to be sold in the market, okay? So how do I do that? I created my new demand function, the shifted one, and I just need to calculate an equilibrium, and that will give me the new quantities. Is everyone with me? Okay. So how do we do this? We take this shifted demand function, we make it equal to the supply function, okay, and we find the quantities of equilibrium. Oh, sorry. That is 42 minus 636. Okay, so this 6 I subtracted from the 42 here. I put the two quantities together on the other side. I get 4Q on one side, 36 on the other side. 36 divided by 4 is equal to 9, okay? So the quantities that are sold in this market with the tax are 9, right? So I have this height here. So the deadweight loss is equal to 12, the amount of the tax, times the difference in the quantities, which in this case is 3, okay, divided by 2, because that's the area of the triangle there, right? And that is 12 times 3. Okay. This is equal to 18. So, because these quantities are in thousands, is 18,000. Everyone with me? Yes.
Sorry, I'm just confused how you got 9 as clusters.
Because I divided 36 by 4.
Why it only affects demand curve? Why does no changes on supply curve?
Okay. When they are talking about a tax, right, of a lump sum tax, it doesn't matter if it is on the supply curve or on the demand curve, right? So I decided to do it on the demand curve. If you want to do it on the supply curve, you do the same thing. Price times, plus the tax equal 6 plus 2.5 times Q, okay? So you will be shifting the supply function. I always shift the demand function, but that's me. You can do it with the supply function too, and the result is the same. Here you are moving the demand function, the amount of the tax. In the other case, you will be moving the supply function, the amount of the tax, okay?
But is it possible both demand curve and supply curve, they both move simultaneously?
They can tell you in the next, I think in the question 17, they tell you there is a tax on the supply side and a tax on the demand side. But at the end, because it doesn't matter, you can put the tax together on one only, right? Another question? So she was asking if it is possible to have a tax on the supply and on the demand function, and I say that yes, but at the end it doesn't matter because you can put that tax that you put on the demand and the supply in just one side and create the calculation. Yes?
You put the tax on the supply equation when you get a negative intercept.
12, 6. Yes, but remember that in economics, we only think about this quadrant. So the supply function will start like around, no, you won't get a negative intersect. Oh, yes, because this is minus 12. Yeah, you will move it. Let me see. Plus 12 equals 6 plus 2.5 Q. Yeah, so your supply function minus 6 will be here. Your supply function would look like this, right? But it doesn't matter because you only care of this, right? So this will give you a very weird producer surplus because it will be like a trapezoid like this, okay? Yes? The tax, oh, yes, you're right, I'm sorry.
You can just look at it as the difference between the price of demand and price of supply, right? The price that the buyers pay and the price suppliers pay, the difference between the two is always going to be the tax. So if you set the equation like that, right, just PG minus PS equals the tax, you can solve for points, and that would be the.
Yeah.
And then you don't need to think about shifting curves. That might be a bit confusing. So just the difference between.
Or the way you think about this is also, I do it in the demand because in the demand is price plus the tax. In the supply is what? The price minus the tax because the producers are getting their price minus the tax. So I made a mistake from your answer, and it's in the supply function is price minus the tax, okay? So in this case will be price minus 12 equals 6 plus 2.5 Q, price equal 18 plus 2.5 Q. So the supply function shifts up like this, okay? Is that clear? Okay, I'm sorry for the confusion. Okay. I always do it on the demand function because I think it's easier to add than to subtract, but okay. So the answer is A. Oh, I'm sorry. Question 15. Suppose demand is given by the suppose demand is given by equation as before. If the supply equation changes to this instead of the equation written in the scenario, would deadweight loss decrease, increase, stay the same, or cannot be determined? What do you think? So previously, right, my demand function remains the same. Supply function changes. It was 6, intercept 6 here, and then a slope of 1.5, right? Now, my supply function changes. The intercept changes, and also the supply function is flatter, right? Sorry, before it was 2.5, now it's flattered, is 1.5. And here it changes. Let's say that this is. Okay, so what was the, if there is a tax, okay, my deadweight loss here was this, right? And here, if there is a tax, what do you think happened with the deadweight loss? Decrease, increase, or stays the same? Decrease. Because my supply function is flatter, right? Okay.
Keep the tax the same.
If you keep the tax the same, I'm sorry. But that was what I was doing. Okay, now you can see it better. Here, you have this one that is steeper, right? And here, this one is flatter with a slope of 1.5. So the deadweight loss here is higher than here. So the answer, when the supply curve changes to a more elastic curve, the deadweight loss increases. Okay? Why? Because when something is more elastic, it means that the response to a change in prices is higher. So when there is a higher response to a change in prices, right, the market is gonna respond more to this change. Therefore, the deadweight loss is gonna be higher, right? The quantities are a response to the change in prices is a change in quantities. Therefore, the quantities are gonna change more, and the deadweight loss is gonna be bigger because the tax remains the same, but this difference here is higher, right? Question?
Yeah, is there a way to do it mathematically, like using the deadweight loss formula?
Yes, well, because what is the deadweight loss? Is the tax times the difference between the quantities, right, over 2. So here, if you find this new equilibrium here and this new equilibrium here, right, and calculate the difference in quantities here and the difference in quantities here, you will get that this one is 4 and this one is 3. You want me to do it?
Yeah.
Okay, yes. So the equilibrium, the equilibrium with this new supply function is how much? It's again, price equal 18 plus 1.5 Q, okay? And the supply, the demand function is 54 minus 1.5 Q, okay? Right? So if you solve this equilibrium, the price is gonna be also 36 and the quantity is gonna be also 12, okay? Okay, so let's use the tax that we were using before, right? The tax that we used before, which was 12, gave us a deadweight loss of how much? 18,000, right? 18,000, okay? Now, so this is with the previous supply function, okay? Now, let's do the same. We have that the demand function changes with a tax of 12. Okay, this is equal to 42. Thank you. Okay. Oh, I'm sorry. Price is equal to 54 minus 12 minus 1.5 Q. Okay, so what we have now is 18 here, the supply function, the demand function, 54. Here is 42. This is the amount of the tax. My equilibrium was the same, 12 and 36. Is everyone with me? Okay, so I need to find the size of this triangle. I know that the tax is 12. I need to know the difference between these two. So what I need to do is make 18 plus, okay, 18 plus 1.5 Q equal to 42 minus 1.5 Q, okay? So this is 18 plus 42 equal to 3 Q. This is 60, am I right? Yes, equal to 3Q, okay? 60 divided by 3 equal to Q is 20, okay? So, am I doing this correctly? Oh no, this is subtracting. I'm sorry. Okay, is 3 times Q, it cannot happen. Minus 18. Why am I doing this? That's 3Q. Okay, let's do it this way. Okay, now. Quantity cannot be increasing with a tax, so I was making a mistake. 24, okay. I always allow my students to bring a calculator because I am very slow with that. Okay, so the quantity is 24 divided by 3, which is equal to 8. Thank you. Okay, so quantities change to 8, right? So the difference between the actual quantity and the equilibrium quantity and the quantity with the tax is 4, right? So 12, which is the amount of the tax, times 4 divided by 2 is the new deadweight loss, okay? Which is 12 times 4 is 48, no? Yes, divided by 2 is 24, right? So before it was 18,000, now it's 24,000, right? So this is a way to show algebraically that the amount of the deadweight loss increases, okay? So again, the only thing that you have to know here is how to calculate the deadweight loss. So how do you do it? You plug the tax either in the supply function or in the demand function. If it is in the demand function, you add the tax to the price, right? You create a new demand function, find the new equilibrium quantity, find the difference, multiply the tax times the difference, divide by 2. Okay? Clear? Good. So the answer is B, it increases. Now, 16. Again, if the supply equation was this, instead of the equation written in the scenario, would the tax incidence on the sellers decrease, increase, stay the same, or cannot be determined? So, how are we measuring the tax incidence? Yes?
It's portion under the price.
Is this on the sellers in this case? Is
Right, exactly. So
this
add to the whole thing.
to the whole thing, right? So this is price of equilibrium minus the intercept of the supply function divided by the intercept of the demand function minus the intercept of the supply function, okay? So what happened? We had a change. We moved from this first equilibrium where this was 6 and this was 54, okay, to another equilibrium where it looks like this, okay? So this is 18. This amount here is smaller than this amount here, right? Compared to the whole difference. Is that clear? So what happens? It decreases, okay? Because here is 36 minus 18 divided by 54 minus 6, and previously it was
The denominator is minus 18.
54 minus 6, no?
But we have the new supply.
I'm using the new supply.
Right, but the denominator too.
B of S for both.
Oh, okay. B of S, oh yes, I'm sorry, thank you. So this is the new supply, this is the intercept of the supply function, this is the intercept of the demand function, this is the equilibrium price, and this is the intercept of the supply function. Versus before, that it was 36 minus 6 over 54 minus 6. Am I right now? Yes, okay? Okay. Now, suppose a tax of 1.92 per unit is placed on buyers and a tax of 2.02 per unit is placed on sellers. What is the proportion of tax incidence on buyers? So what happens? Again, as I said before, it doesn't matter if the tax is on buyers or on sellers, the tax incidence remains the same, right? So you can basically ignore these two numbers and check what is the tax incidence demand, supply. This is 54, this is 6, as in this scenario, okay? And you need to calculate the tax incidence on buyers, which will be B of the buyers minus the equilibrium price over B of the buyers minus the B of the sellers, okay? Is this ratio of this difference, 36, the difference between 54 and 36 over the difference between 54 and 6, okay? So this is 54 minus 36 divided by 54 minus 6. This is equal to where is that? 18 over 48 equal to 3/8. So the answer here is C. Okay? Any questions on that? I was hitting this all the time. Okay, you don't have because I was hitting this.
Where is the clicker? Thanks. Okay, so let's move on to question 18. All right, so question 18 asks us the following. Suppose the government has adopted a point on the increasing portion of the Laffer curve. Which of the following statements is true? So, recall that the Laffer curve basically plots the relationship between the tax rate and the tax revenue. So it looks like the following. If we were to graph, can everybody see the red?
Yeah.
If we were to graph the tax rate against the tax revenue, we would see the following shape. Where for a tax rate of 0, we would expect to receive 0 revenue. Then for a while, as the tax rate increases, we would expect there to be an increase in revenue. And then after a certain point, as the tax rate gets to be a little too high, we might expect some economic effects to be happening behind the scenes, which would actually potentially cause the tax revenue to decrease. Okay, so we're all familiar with the setup here. So, if I were to tell you that we were on the increasing portion of the Laffer curve, in other words, on this segment right here, what could we say about the slope of the Laffer curve? Choice B. at that current level of taxation? It's positive. So we can automatically cross off B. We have a positive slope. Now, what could we say about the revenue at this point on the curve? If we were to increase the tax a little bit more, in other words, if we were to go from, let's say, this point here to this point here, what would happen to the revenue? It would increase. So what do we do with choice C? Cross it off. So we've already eliminated two choices. Now, the next two answer choices, in order to figure out which is the right one, we want to think about the relationship between the deadweight loss and the tax rate. So what happens to the deadweight loss when we increase the tax rate? It increases. So an increase in the tax will cause an increase in the deadweight loss. So we definitely know that answer choice is correct. All right, so do we even need to bother talking about A? What does efficiency mean in this context?
It does not improve the increase.
It doesn't?
It does not increase.
It does not increase, right? So basically, as a deadweight loss increases, efficiency is decreasing, okay? Which basically means that the deadweight loss is basically an increase in the burden to society. So as the society is taxed, the society is burdened by this tax, which is inefficient. So deadweight loss goes up, efficiency goes down. There's an inverse relationship between those two, yes.
For choice C, if taxes increase, we should go, and if revenue will decrease.
Right, so the key point here is that we are on this segment of the curve. So,
The whole time.
right.
So then can you explain choice D?
Sure. So choice D tells us that an increase in the tax will result in an increase in the deadweight loss. Now, regardless of where we are on the curve, as tax increases, right?
Automatic.
You're a customer, you're going to a store, you want to buy a pair of jeans, okay? Suddenly you face a tax. That affects you, regardless of whether you are here or here, regardless of how much that tax is, you're still impacted. You might be paying more, right? So there's automatically an increase in the deadweight loss. Okay?
Yeah, thank you.
Sure. Any questions about this? All right, great. Let's move on. So the answer choice we said was going to be D. Excellent. All right, question 19. So, suppose the total revenue of all firms in equilibrium is 25 million, and the price elasticity of demand in equilibrium is 0.8. Okay? So if there is an increase in the number of firms in the market, what happens to the total revenue? So how are we going to figure this one out? What information do we have? So we're given this price elasticity of demand, and we do know that based on what that number is, we can already tell some things about okay, so we know that the price elasticity of demand, who remembers the formula for that? We've seen it several times today. I'll write it down in the following form. It might differ from some of the ones you've seen earlier, but they all mean the same, and if you do the algebra, you should be able to figure that out. So basically, the change in the quantity, price elasticity of demand, demanded over the change in the price times the price level over the quantity will give you the price elasticity of demand. So we're told that this quantity is now equal to, well, not this quantity, but this overall expression is equal to 0.8. So we know that this number is greater than 0. What does that tell us about the kind of good that we're dealing with?
It's slightly elasticity.
I'm sorry, I can't.
I say it's slightly elasticity.
Slightly elastic?
Elastic, yeah.
Okay. So we're getting to that in a second, but when the price elasticity is positive, what kind of good are we dealing with?
That's not it. It needs the proper one is 1, right?
Yeah.
It's unit elastic, so less than 1, more than 1 is the difference. Right?
So I'm going for 2 points. I'm going for whether it's elastic and inelastic. So that tells us,
That's what
This is inelastic.
Elasticity is never negative, so you can't do it.
yes, it can be. It can't? Okay. Well, I'm going for the following. I'm going for the fact that it's a Giffen good. So basically, if the price increases, the demand increases, right? And then as the number of firms increases, price goes down, so demand goes down. That's not the right path? Okay.
There's
So,
no income effect here, right? We don't know what change in income is.
all right. So,
We just know it's inelastic, and then we look at change in total revenue of the producers.
can you say that again? I didn't hear.
Well, if we're gonna look at, we asked about revenue, right?
Yeah.
So total revenue is quantity times price,
Yes.
right? This is 1. Total revenue 2 is quantity 2 times price 2, whatever 1, 2.
Okay.
So the change in total revenue is what we're after.
Okay.
It's gonna be the change in quantity times the change in price,
Okay. Got it.
right?
So,
And this is less than that, right? This goes
right. So that's
up, the other
positive.
goes right. But the quantity, because the elasticity is 0.8, then if you change the price by 1, this is only gonna change by 0.8.
Okay.
And this is a, what is it, negative change?
No, they're not saying anything
this
about.
goes down, this goes up, but this goes down by more than this goes up.
How do we know that? If this goes down?
Because the elasticity is change in price, and it's less than 1, right? So if this changes by 1, this changes by 0.8.
Okay. Any questions about this?
So because it's inelastic, what happens? If there's an increase in the number of firms, revenue would go
We
down.
have the microphone, I'll take care of this one.
You want to do this one? Okay, guys. Victoria's taking over.
No, just for this one, it's okay. Right. So what's going on here really? We have demand, supply, right? We know that there's an increase in the number of firms, right? Does that affect the demand curve or the supply curve? In such a way that it shifts to the left or to the right? Okay, so we have a shift in supply. That's the new supply curve. What's the consequence that we get from this? First of all, compared to the equilibrium, the price has gone down, right? The new price is lower. Quantity in equilibrium 1, quantity in equilibrium 2. So quantity goes up, price goes down. Okay? So these are the two effects. So the change in quantity is positive, and the change in price is negative. All right? And the change in total revenue is going to depend on how much the price and the quantity changed, right? So we know that price went down, and we know that quantity went up. True? But we don't know by how much, because we are not given that exact information. But we're given the elasticity of demand. So we know that if you change price by 1, quantity is going to change by 0.8, by less than that. Right? Because it's an inelastic curve, then the response to a change in price is not going to be that much. So when the price is going down, right, quantity is going up, but not as much as the decrease in price. So that's why the total revenue is going to go down, because the thing that decreases is decreasing more than the thing that increases. Does that make sense?
How do we know that it's decreasing more?
Because of the elasticity. Because the elasticity is basically the change in quantity over change in price. That's what elasticity is. And this is, right, this is 8 over 10. Basically, so if the price changed by 10, quantity is going to change by 8.
Or as I said, elasticity is a measure of the responsiveness of one market to a change in price. So if there is a change in price and it's very elastic, the market responds more to it. How? Changing the quantities a lot or a little. In this case,
They can't hear you, so I'm going to repeat. So what Paloma pointed out is that the elasticity is, again, the responsiveness of the market to a change in price. Okay? We have a decrease in price. The response is an increase in quantity. As a buyer, if price goes down, you're going to want to buy more, right? Because it's cheaper now. But because the elasticity is not as big, when the price goes down, you're going to increase your consumption, but not as much, right? Therefore, the total revenue of producers, right, of suppliers is going to go down. This is equivalent to making let's say you have a sale on something, right? You decrease the price, buy one, get one free, right? If the demand for this good is very elastic, right? Even though you cut the price, you're going to get so many new customers buying that your total revenue is going to go up. But if it's inelastic, as in this case, so you cut the price in half, right? Buy one, get one free. But not too many people are coming in, right? Not too many new people are coming in taking advantage of this. So now you cut the price a lot, you don't get new customers, total revenue goes down, which is what we have here. Right? Does that make sense? Yes. All right, good. Sorry.
Everybody got that?
Elasticity would be over 1. It would increase the revenue.
Right, so if they were over 1, it would basically mean that an increase in the price would be smaller than the increase in the quantity. Any other questions? All right. Okay, so let's move on to question 20. So this was D. No, this was A. What am I doing? There we go. Okay. Question 20. So question 20 presents us with a scenario in which we have two goods. We have good X and we have good Y. And we're told the following. We're told that 14,000 units of good X are sold when good Y has a price of $8. Then we're also told that 10,000 units of good X are sold when the price of Y is $10. And then we're asked, what is the cross-price elasticity of demand? So recall that the cross-price elasticity of demand is basically the responsiveness of the quantity demanded of good X to a change in the price of another good Y. Okay? So we can calculate the cross-price elasticity as follows. We write down the general formula. So I'm going to call the cross-price elasticity just E. If you're used to a different notation, just bear with me. And we're going to write down that this is equal to the following. Q2 minus Q1 over Q2 plus Q1 divided by 2. In other words, the change in the quantities demanded of good X over the midpoint of the two quantities, in other words, the average. And we're going to divide that by the change in the price for good Y divided by the average of the prices. Okay? So let's say we take X equals to 14,000, PY equals to 8 as the two quantity and the two price. In other words, the variables here indexed by 2. And we take the other one, X equals to 10,000, and PY equals to $10 as the quantities and prices indexed by 1. Okay? Just so we're all clear when we're filling in this formula. So this is those indexed by 1, this is those indexed by 2. So then we have all the information we need to find the cross-price elasticity. So Q2 is what? Quantity of X? 14,000. We're using the first piece of information as 2. So we have 14,000 minus 10,000. And then we are dividing that by that midpoint, the average of the two quantities, which is 12,000. Excellent. And we're dividing that by the change in the price, P2 minus P1, which is P2 is 8 minus 10 divided by the midpoint. So 8 plus 10, 18 divided by 2, which is 9. Good. When we simplify this, what do we get? So we get 4,000 divided by 12,000, which, yes, is a third, divided by minus 2 over 9. And if you want, punch this into your calculator, or you could do it algebraically by hand. What do we get? One third divided by minus 2 over 9 equals to 1 over 3 times minus 9 over 2 minus 3 over 2, which is? Excellent, negative 1.5. So that is choice D. Great job, guys. Yes?
Sorry. Why did you do 8 minus 10 and not 10 minus 8?
So that was arbitrary. You just have to be consistent. We have two different coordinates, so to speak. We have an x and a py. The first one is x is 14,000, py is 8. That's our first scenario. And then the second scenario, or I should say coordinate because they use scenario in a different way. The second coordinate is x is 10,000 and py is 10. So you just have to be consistent. If you want to label the first coordinate as those indexed by 2, then you have to be consistent, and then the second one is 1. Or you could have done the alternative where the first scenario is 1 and the other one is 2. You just have to be consistent in what you plug in. Okay? We don't want to cross them over. Any other questions about this one? Okay, great. All right, so we're still referring to the same scenario. What word best describes goods X and Y?
Substitutes, because when the price of one increases, the demand for the other also increases.
So maybe we should write it back out. So in the first scenario, we had X equals to 14,000 for PY equals to 8, right? And in the second scenario, we had a reduction in the quantity of X, which was 10,000, but we had an increase in the price. So basically what's happening is that when the price of Y increases, so PY increases, there's a decrease in the quantity of X. So basically when the price of one good increases, and that causes a reduction in the quantity demanded of the second good, we call these goods complements, right? When you go to the store and you want to get a hamburger, if the price of a hamburger goes up, you're probably going to buy less ketchup, right? Because you want to consume them together. Okay? So the answer for this one is going to be C. Any questions about this? Okay. All right, question 22. Suppose the willingness to pay of Thomas, George, Abe, and James is $25, $14, $19, and $16 respectively. Now the actual price is $17. So what is the consumer surplus? So how are we going to do this one? We have these four guys. We have Thomas, we have George, we have Abe, and we have James. Their willingness to pay is $25, $14, $19, and $16. But the actual price is $17. So which of these guys are actually going to be purchasing the good? Yeah, Abe and Thomas. So how do we calculate consumer surplus, given willingness to pay and the actual price faced? Perfect. So the consumer surplus for Thomas is going to be equal to 25 minus 17, which is 8. Excellent. And now the consumer surplus for Abe is going to be, so his willingness to pay is 19, excellent, minus 17, which is 2. Now, why don't we have a consumer surplus for these guys? They're not buying the good, okay? So the overall, the total consumer surplus is equal to 10. Excellent job. So that is choice B. Questions about this one? Okay, great. We're almost done, guys. All right, so 23. What is the potential unintended consequence of a price ceiling? So what is a price ceiling? Excellent. So graphically, what does that look like? Let's have a look. If we're looking at our usual supply and demand framework, quantity on the x-axis, price on the y-axis, and we have our demand curve, our supply curve, and we're told that we faced a price ceiling. So that basically means the following. The equilibrium point in this system is defined by that intersection right here. The price ceiling tells us, however, that we cannot exceed this price. Okay, there's this price right here, and we're locked in. We can't go above. In other words, we can't reach that equilibrium point. So we're stuck here. In other words, we're stuck at this point on the demand curve and this point on the supply curve, which tells us the following. The quantity demanded is all the way out here. However, the quantity that's actually supplied is all the way down here. So what can we say about the quantity demanded relative to the quantity supplied? It's bigger. And we call this a shortage. So now that we know we have a shortage, let's have a look at the answer choices. Excess inventory. No, excess inventory means we have excess supply. We have a surplus. That's not the case. We crossed that one off. Sellers offering illegal low prices. Why not? There's a shortage, so?
Things are more valuable.
So they're not going to be offering low prices to anybody. Illegal discrimination of buyers by sellers. Why? So suddenly I'm the seller in this market, and I have tons of people who want to buy my stuff. I know that if I'm mean to this guy and I say, you don't have to buy my stuff, or I don't like you, or I don't want to sell to you, I'm not worried. Because the next guy who walks in is going to be willing to buy my stuff. And there's so many next guys because the demand is so much bigger than the supply. So I can choose who I want to sell my stuff to. I can discriminate. Okay? So the answer choice for question 23 is C. Yes?
Price ceiling can only be under the equilibrium.
So here's the point. I've gotten that question before. Let's say it weren't. Let's say we had this price ceiling and it was here. Would that actually be binding? Would that affect our system in any way? So the goal is to be down here. That's the equilibrium. That's the optimal point in the system. If I'm told that I can't go above this line, well, that's very nice to know, but I don't especially care because I want to be down here. So if I were to face a ceiling that's up here, it wouldn't be binding. I wouldn't bother to refer to it as anything in particular because I'm interested in a point way below. So we call it a ceiling when it actually stops us from moving up, when we want to move up. Okay? Are there any more questions about this one? All right. 2 more, guys. All right, if deadweight loss is $10,000 under a tax of $1 per unit, what is the deadweight loss under a tax of $3 per unit? So to answer this question, remember the formula that relates deadweight loss to the tax. The deadweight loss is equal to 1/2 times the tax times what we call, I'm going to call this QE, which is the pre-tax equilibrium. Thank you. And I'm going to call this quantity Q T, which is the post-tax equilibrium. Just check that I've written that right. Yeah. So, oh, so sorry, guys. So if I'm facing a tax of $1 and I have, oh, thanks, guys. So if I'm facing a tax of $1 initially, and I'm told I have a deadweight loss of $10, that's useful information. And that's going to help me figure out what the deadweight loss is when I have a tax of $3. So here's how it works. If the tax increases by a multiple of, let's say, C, just an arbitrary constant, then the distance between these two quantities also increases by a multiple of C. So here's what I mean. If this is the formula that relates deadweight loss for a certain tax, I'm going to write deadweight loss as a function of the tax, which is just this T right here, is equal to 1/2 times that actual tax, QE minus QT, then increasing the tax by a constant, C, is going to not just increase the tax, but it's also going to increase the distance between these two quantities by that same amount, C. So C in this case, this multiple, is what? 3. So I'm told that the deadweight loss of 3 times this tax, $1, is equal to 1/2 times 3 times the tax times 3 times QE minus QT. So if I plug in 3 in those relevant spaces, I am left with the following. I have a 3 here and a 3 here. What's 3 times 3? 9. That's a constant. I can pull that out right here. So I have a 9. I have 9 times 1/2 T times QE minus QT. Right? I factored out this 3. And what do we see here? This is just the same thing as the deadweight loss that we had earlier, which we were told under the $1 tax regime was $10,000. So I basically now have 9 times the initial $10,000, which means that the new deadweight loss is $90,000. Excellent. So basically what we know from here is that the tax increases, the deadweight loss increases, but the deadweight loss increases not linearly with the tax, but as a function of T squared. C squared. Okay? So deadweight loss of C times the tax, if I rewrite this expression right here, is 1/2 C squared T times QE minus QT, okay? So this C squared is what distinguishes the new deadweight loss from the previous deadweight loss. Any questions about this one? Yes?
In this two scenario, the QT should not be the same one. I mean,
It's not the same one.
but now, for example, like when you plug the
It-
$3, the situation inside in the $1, we use the same QT, but the QT is not the same one.
So the distance between the two, it's a different one, but we're dealing with the distance, right? So it's not about an absolute point, it's about a distance. Does that make sense?
The distance is not the same.
It's not. It increases by the same multiple. Right?
Meaning that the t is such that the distance between them is going to be 3 times larger.
So in other words, I have these 2 points, like I could look at a number line, this is 3 and this is 6. It doesn't matter whether this is 3 and 6, whether this is 6 and 9. I'm looking at the difference between the two. So I
That like a unit, this is 3 times more than that.
exactly. I care about the distance,
Okay.
not about the absolute numbers on either end of that distance.
Okay, got it.
Okay? And we're saying that the distance is increasing by that same multiple, by that c. Okay? Any other questions about this one? Yes?
Okay, so C is the ratio between the tax and the old tax?
So C is not exactly a ratio. It's basically the multiple of the increase. So my initial tax was $1. Now my tax is $3. So it basically increased by a multiple of 3.
So what if it was $4?
So then it would have increased by a multiple of 4. Okay? And then I would just have plugged in 4 in here. And instead of getting 9 times the initial tax, I would have gotten 16 times the initial tax. Excellent. Okay? Any more questions about this question? Okay, guys. So, we're skipping back and forth. All right, so the answer here is going to be D. Excellent. 25, last one. What is the income elasticity of demand for a normal good? All right, so what do we know about a normal good? Why do I keep going back and forth? What happens to the quantity demanded of a normal good when income increases? So the income elasticity of demand, I'm going to write this as income elasticity of demand, IED, is equal to basically the change in the quantity over the quantity, the change in the income over income. So if we know that for a normal good, as income increases, quantity increases, what do we know about the sign of this term, the sign of this income elasticity? It's positive. Can we explain that a bit further? Why? Why is it positive? How do we know that? Yes?
If either variable were negative, in which they're not, because they're both increasing, the entire fraction would be negative.
Excellent. Well said. So the gentleman here is saying that I know that income is increasing and quantity demanded is increases, so all these numbers here are positive. So I'm dealing with a positive number. It's as simple as that. Okay? So what's the answer here? B. Okay, questions? All right, guys, great job. I'll let Victoria wrap up. We're done? Okay. Thanks, guys.